So this is our Truss Bridge exhibit. You're presented with a river with two branches and a load of balls stuck to the base. And you have a box full of sticks. Some of these sticks have balls on the end, and there are magnets on the sticks, so you can stick them on. And the challenge is to try and build a bridge across the river in all the three places. Now, if you just try and put the sticks together like this, and you just use the straight ones, you end up with very weak structures which won't stay up. If you use some of the slightly longer sticks, diagonally brace them, you can suddenly start building quite rigid structures. And by going along with like this and sticking your bridge together, you can start to build a truss, which are an incredibly common engineering feature. And I mean, obviously it's quite easy to build a bridge across, but you can build quite a nice bridge which will get across there. Now, of course, if you want to go a bit further, you've got to do a bit better. So we can try the second bridge. We have a nice little truss bridge across the river, and then the sticks with balls on the end have got a white bit at the end to indicate they've got balls on the end, so people don't spend the whole time trying to rip the balls off. And they're stuck on this, so as it's much harder to swallow a ball on a stick than just a ball on its own. And so we can start trying to build a bridge across the longest one. And so we've built three reasonably robust bridges across the river using really quite a weak building material, which is of course why so many bridges are trusses in the real world. You're not actually constrained to square girders. You can actually build triangular ones too, because that just involves, you can make an equilateral triangle by using two of the short sticks. In pretty much the same way as you would build the rectangular girders. Which produces something which is quite like a house in its shape, which is kind of satisfying. Of course, if the fancy takes you, you don't have to build horizontally, you can build upwards. One of the lovely things about all the joints being magnetic is that destructive testing can be encouraged rather than worried about. So if you just keep pushing until everything collapses, nothing's gone wrong. All the parts are just as good as they were before. This exhibit specifically has been built to be mounted temporarily on a folding table. So we've built a system with these clamps and a series of holes, so you can clamp it to the table quite securely. And then at the end of the day, or if you want to change the use of the space, you can just unclamp it and put it in a cupboard. We've also used this system in earthquake tables, so you can try and build a tower to survive an earthquake, and just with a grid of balls on the floor to let people build whatever they want to build.